In this problem, we're asked to find the magnitude of the line voltage at the load. The load is modeled by the impedance 9 plus J6 ohms. We have a line impedance and we have a three-phase source. Notice that this is a balanced three-phase circuit. The voltages have the same magnitude, they're 120 degrees apart. The line impedances are the same, the load impedances per phase are the same. So this is a balanced three-phase circuit. We'll utilize our problem-solving strategy entitled Three-Phase Balanced AC Power Circuits. And step 1 there says convert to a Y-Y connection. And if we look, we have a delta-connected load and a delta-connected source. So our first step in this is going to be to convert to a Y connection. And then once we do that, we can draw the A-phase circuit. So if we look at our circuit, for instance, VAB is 215 at an angle of minus 10 degrees, volts RMS. And if we look, this is an ABC set of voltages. VBC is an angle of minus 130, so that lags VAB by 120, and then VCA is 215 at an angle of 110. That leads VAB by 120. So if we go to calculate VAN, so that we can draw our A-phase circuit, the magnitude will be 215 divided by the square root of 3. Because VAB is a line voltage, VAN is a phase voltage, and then to get the phase, this is ABC phase sequence, we'll subtract 30 degrees, so we'll get 124.1 at an angle of minus 40 degrees volts RMS. So now we've got the phase voltage for the A phase, and now we have a delta connected load, and we remember ZY is 1/3 Z delta. And our delta impedance is 9 plus J6. So ZY then is 3 plus J2 ohms. So now we're ready to draw our A-phase circuit. Because we've calculated all the quantities necessary. So here's our A-phase circuit. Here's our load converted to a Y line impedance. Here's VAN. So now we can calculate a current. It's 124.1 at an angle of minus 40 divided by 0.05 plus J.1 plus 3 plus J2. So that current is 33.5 at an angle of minus 74.55 amps RMS. So V cap AN then, the phase voltage of the load is 3 plus J2 times our current that we just calculated, and that's 120.8 at an angle of minus 40.86 degrees volts RMS. So then the line voltage at the load is going to be the square root of 3 larger than the magnitude of VAN. So we have the square root of 3 times 120.8. That's 209.2 volts RMS.